This video is going to be about stall on wind turbine blades, and for this we're going to look at this model here, and so nothing is moving, so the blades are still, but they're pitched 90 degrees, and the wind is actually the one that is rotating, so that's going to create a change in the angle of attack. And what we're going to look at is, so I'm going to add a field which is going to be angle of attack versus lift here, and I want a 10 degrees variation, or 20, 10 on each side for the angle of attack, 1 for the lift coefficient, and maybe 150 points. And if I plot this now, so when I press play, what you can see here is the angle of the lift coefficient depending on the angle of attack. And actually, so we're looking at blade station 15, which I think is this one. Yeah. So I can open the velocity triangle here, and what I want to see is the polar curve here. And so what I have here is basically the same thing as what you have here. Okay. So what you have here is that the line kind of the point kind of moves along this line here. If I press play, you can see that this line is moving, and that's what this point is doing here. And I mean, I guess this makes sense, right? You're like, just looking at this curve and increasing and decreasing the angle of attack, so then the lift coefficient goes, up and down. But in real life, that's not actually what happens. This is a static curve, and that's not what you would see in a wind turbine. So if I change from steady aerodynamics to unsteady, and then what we'll see is, because if I start my simulation now, again we can look at this same graph here, and well, there's some transitions, but now what you see is that we're not following the line anymore. There's like this, this is the point that we're following, and you can see that there's like this hysteresis now. And and if I pause this again, so now like instead of being on that curve, I'm somewhere kind of around it. So now when I increase and decrease the angle of attack, the lift coefficient varies like this. There's kind of this this hysteretic loop that you can clearly see here on this graph. And well, my understanding is that this is because stall occurs when there's flow separation, right? When the flow is not attached to the airfoil anymore. But what happens is that the location of this point, so the location of the separation point, well, there's a bit of delay. If you increase the angle of attack, it kind of it remains at the place where it is, and then it kind of moves along the airfoil. But there's a little delay in how that happens, and that's why there's this dynamic stall phenomena. So I hope that this made sense, and as always, just like and subscribe if it makes sense, and see you around.